You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Welcome to another episode of Complete Developer Podcast. We've discussed the pillars of object-oriented programming in the past, and this week we're talking about core concepts of functional programming. We'll start with a review of the general concepts that apply across all programming languages, then briefly introduce functional programming before discussing the concepts behind it. But before we get started, Will, what have you been fighting this week?
I have been finishing up my end of the year things that I could do. I had a bunch of stuff that I was planning on doing before the end of the year that just didn't happen because the deck is still not done. But I'm trying to get ready to, start my New Year's resolutions because it's sort of important because it's the new year now. Did a bunch of writing on the book yesterday. That's cool. I did binge writing. Other than that, I have been bashing my head against the wall with bash scripts. And I think you got to see some of that experience today. I'm trying to write the, just our little maintenance scripts. Cause, when you record as much audio as we do, you end up with a whole lot of data that you've got to deal with. And I've got a box that has 12 terabytes of storage on it. We have C-file on there for synchronizing everything. And of course, you don't want all the, previous episodes need to get off of your box, and it needs to happen in a maintainable manner that gets it compressed and gets it where it's in storage somewhere and it's just there and it happens transparently. So I'm building bash scripts to do this, and I had it with Robocopy before. And now I'm learning how the other half lives. And there's been a few quirky little things that I've had to try to figure out, particularly like with the find command in Linux. On bash, because it's like I was initially going, okay, I can loop through all the directories that match a certain pattern and then do something with that. And you can, but everybody's like, oh, well, this will cause a problem if somebody drops another folder out there at the, and so it's like, okay, you call this find thing and then you pass it the code you want it to execute. And this is on the command line. Mm-hmm. And it supposedly does it, but I can't figure out how to get it to execute two commands. That's where I am right now.
Okay, I got
fighting with that. It's just little irritating stuff like that. It's like, oh, I gotta, I'm gonna have to spend a bunch of time on this. That's what I'm doing at the moment. It's not bad, and I need to brush up on the bash stuff, but it's just another little challenge. So how about you?
Well, I haven't been doing much lately. One of the apps I've been working on at work goes to pilot this week, so my focus has pretty much been on last minute bug fixes, were mostly typos. And while we were between bugs, one of the other devs and I started looking into refactoring some of our code using Angular components. It's pretty cool. We started a Pluralsight video on it, though I did miss a bit of work last week because of food poisoning. To quote, "He who shall not be named, don't eat used sushi."
Yeah, I've gotten sick from sushi before. It's been a couple, 3 years, but when it happens, man, it's just, you're not going anywhere.
Oh, yeah. It was.
Well, you are going somewhere, but it's not very far. It's the place with the white seat down the hall.
Yeah. It was like a scene from The Exorcist at my place. I was out of commission for several days and actually just started eating solid food yesterday. That nastiness aside, let's go ahead and roll the music. This week for IoTs, I have a fun project. It's a game system in an Xbox controller, and I'm talking about the old school, large Xbox controllers. Oh my goodness, I had forgotten how big those things used to be until I saw the tutorial for this. It uses a Raspberry Pi Zero, because I'm still on my Raspberry Pi Zero kick, and in this tutorial, it shows you how to build your own game console in the controller. You'll start by taking it apart and placing the Raspberry Pi inside the controller. Then you'll convert the Xbox controller cord to USB and basically plug the controller back into itself, or more accurately, into the Raspberry Pi that is now in the controller. Flash the RetroPie games onto the Raspberry Pi Zero, and with a little configuration, you have an entire game system in a controller. I'm thinking this might be the next Christmas present I put together for my nieces. So who's talking to us this week?
Well, we grabbed an email from Abhimanyu John Lakocha. I'm not sure if I got the last name right there. It says, "Hey guys, a little about me. I'm a junior developer, started coding in the beginning of 2015. Currently in college going for a double major in economics and computer science with a minor in math. Currently preparing for a programming job that I'm starting next month using Visual Studio. It's ASP.NET, MVC, and Xamarin. That's right up our alley pretty much. And he says, over the last half a year, I've been busting my ass to learn TDD, unit testing, mocking objects in various languages and tools like C#, JavaScript, jQuery, HTML, CSS, and Bootstrap. I recently decided to start listening to podcasts again and decided to look for a developer podcast. I picked a random one from the list, being you guys.
Awesome.
Yeah. You guys are truly motivating. You'd all mentioned the importance of SQL. I know the basics, but I heard you use some keywords like inner join, right join, etc. And I realized I did not really know what you were talking about. So I decided to pause the podcast and take a few hours to go online and learn a little bit more about it. You guys are definitely the little push I needed to keep on focusing on learning the tools of the trade." And he closes out with some more information and a sequel joke as well.
Yes.
So, very nice.
I love the sequel joke. It cracked me up, and Will laughed too when he saw it. It's just like, I read that and thought, another code geek. Awesome.
Yes, exactly.
So if you would, send us another message with your contact information, because we've got some Complete Developer swag just for you. And guys, if you'd like your very own Complete Developer podcast swag, leave us a review in iTunes or comment on the website or any of our social media. We post all of our episodes to Facebook, Twitter, LinkedIn, and Google+. We're also on Path and Tumblr. I also want to mention that our friend Bethany Adams has released her second book. So to celebrate, we are running another contest where we'll be giving away an autographed copy of one of her books. It'll be the winner's choice. We'll be announcing the winner the first episode in May. So to enter, you need to leave us a review in iTunes. We love seeing those 5 stars. So before we get into functional programming, I kind of want to go over some of the basic concepts of programming in general. And these apply to almost any language, with maybe a few odd exceptions here and there. Yeah. But these are just the basics of what you're going to find in programming. Now, the first is variables. And I have a quote here from Trevor Page that says, "Variables are the backbone of any program and thus the backbone of any programming language." Variables are basically a way of storing information to be used in the code. Typically, they are labeled with a symbolic name, and that's used to describe the information they store, though sometimes it can be obscured, such as with obfuscated JavaScript, which Will has plenty of experience with, or when you have a bad coder that doesn't understand naming conventions.
Or when you have obfuscated bad code, which, really ties into the, we're about to talk about functional programming style, but that ties into the dysfunctional programming style, actually.
Yeah, exactly. The value or information can be retrieved by referring to the variable's name. Next are control structures, and these are the decision-making parts of your code. They analyze variables and make decisions based on a strict set of rules, and it kind of determines the flow of the code through your program.
Right. Like this is your if statements, your looping constructs, case statements, all that kind of stuff.
Yeah. Next is the data structures, or the way the computer stores and organizes data. These are things like lists, arrays, key value pairs, JSON objects, and
pointers to jumbled morasses of random bytes.
Yeah.
Whatever.
And you can basically, with these, you can add or remove items from the data. You can index them, search them, pull one out, change it, and return it. These are how the computer deals with the data. Next is syntax. This is the language of programming. Syntax is the rules of writing code, kind of like grammar is the rules of writing human language.
Except the computer tends to be a little bit less flexible and tolerant in general.
You did not meet my 11th grade English teacher.
Well, yeah. You've not met some of the programming languages I've used either.
That's true. And finally, there are tools. These are parts of a language used to make coding easier, such as like IDEs, frameworks, libraries.
Yeah, because usually when somebody's talking about a programming language, they're not talking about the language itself. They're talking about the language and its ecosystem.
Yes, unless they're talking about vanilla JavaScript.
Yeah. Well, it still has an ecosystem, right? It has the objects that are living in the browser. It has...
Oh, well, there is that.
It has its runtime. It has its capabilities, its tendency
You're
to be
assuming they're
single-threaded.
using a browser.
It has the tendency to, to leak memory because a lot of programmers are kind of bad at using it. There's all kinds of fun stuff.
Hey, I have written vanilla JavaScript that has never touched a browser and was not designed to.
So have I.
I'm just messing with you, dude. So, a little background on functional programming. I have a fun quote here from Mary Rose Cook. Functional code is characterized by one thing, the absence of side effects. We'll get into that a little bit later on as to what she means there. But functional programming, it's kind of a buzz thing now, but it's not really new.
No, it absolutely isn't. I mean, programming came out of mathematics.
Yeah. And, Haskell is one of the most purely functional languages, and it's been around since, 1990?
I think so. It's been around a long time.
Yeah.
But, I mean, even some of the, some of the stuff with Lisp comes out very functional looking. Mm-hmm. So it's, obviously the side effects thing is still a big deal, but, like, this thing is pretty much baked into the way computers have worked since they were literally computing. And that's all they did.
Exactly. And some other functional languages include Erlang, Scala, Clojure, and F#, which they're primarily functional languages, though they do allow some other things. Functional is a programming paradigm or kind of way of structuring code. Paradigms are ways of classifying styles of programming.
It's also a good way to get 20 cents.
Some languages can fall into multiple paradigms, kind of depending on how the code is written in them. Some paradigms are concerned with the execution of the code, whereas others are concerned with the organization of the code, and still others with the syntactic style of the code.
Right. And it's basically how you express an operation cleanly.
Yeah, exactly. The functional paradigm uses expressions or declarations rather than statements. And expressions are combinations of values and functions that are computed to produce another value. And specifically in functional programming, the result of an expression can be another function to be evaluated. Computation is treated as the evaluation of mathematical functions, and this avoids changing state or mutable data. And outputs are always the same with the same inputs. So they're not state dependent. That is a big part of core concepts of functional programming too.
Right. I mean, and this is based off of, if you remember, there was a section probably early in your algebra class that actually talked about functions, and then you went on and you didn't ever use it again.
Yeah.
You thought, right. But it was the idea that I can pass something in and I get something out, and it's consistent. For what I pass in, I get the same value out every time. In other words, there's nothing inside there that changes. And the variable I passed in doesn't get changed either.
No, that makes sense.
So it's just a fundamental concept of mathematics, and we used it in early computing to do computation. And then we said, hey, wouldn't this be great if we could do this on strings, which are really just arrays of numbers?
Yeah.
And everything else is. And so that's how this got carried forward. So if you think about it in terms of this is something bolted onto algebra, it makes a lot more sense.
That's a great way of putting it. I like that. When a function can change an object's state, it can mess with the concurrency.
Then timing becomes an issue. And I'll give an example for the listeners that may kind of clarify this.
All right.
We're talking about state mutation versus non-state mutation. If you and I have a joint bank account and we both check the balance, we're not affecting each other. So as many people as we want can check the balance. But if we're taking money out and putting money in, somebody's getting inaccurate results or results that change by the time they look at them.
Right. Yes.
That's not what you want. because that makes systems break. So
That's what you're
it's
saying.
that sort of setup. And so that's why the variables aren't.
Yeah.
They don't, it's a thing of, we don't allow, mutation of an object. So it's a thing of, I'm going to, instead of mutating this thing, I'm going to make a copy. And then it's okay.
Yeah, that makes sense.
But you don't want two hands writing on the same piece of paper.
Before we get into the real meat of the episode, or the core concepts, I have a really nice quote from Michael Feathers that kind of compares object-oriented and functional programming. And he says, object-oriented programming makes code understandable by encapsulating moving parts. Functional programming makes code understandable by minimizing moving parts.
Right.
I created this list. I actually stole a list. So
You copied the list
Yes.
in functional style.
Yes.
You didn't take the list. You made a copy so that you didn't mutate the original list.
So I got this list from the Societia, I think, or it's the Society, like drinkingtea.org. You guys, there'll be a link in the show notes.
Yeah.
But it's kind of a cool name for a website. So, but this is a list of 5 core concepts about functional programming. The first is, it is based on lambda calculus.
Right, which sounds massively intimidating until you actually look at what they're trying to say.
Yeah.
And then it's like, this isn't calculus like doing differential equations.
Yeah, it's a lot more similar to what Will described a little bit earlier with the algebra functions.
It's meta math.
Yeah.
Is what it really is.
is.
And that's why they said, it's calculus. It's like, okay.
Yeah.
You run with that, man.
They call it calculus because meta's hard, man.
Yeah.
But then there's a few things from that, the lambda calculus, that we're going to go over, and there's more to it than I've got here. And what I have here is actually more than was in the material on functional programming.
Right.
So, first off, all functions can be written anonymously.
In other words, the function is usable in a context. It's not bound to the context. It's not mutated by where it's living.
Yeah.
That's what they mean by anonymous.
The only things that are really needed from the function header are the arguments being passed in, or the inputs.
Right.
And
the order of them, arity and all that, but it's a signature.
Interestingly enough, this is where the term lambda functions gets its name.
Yep.
From the fact that lambda calculus, all functions can be written anonymously. Also, all functions go through currying.
Yes, and this is not referring to, lightly dusting them with turmeric and putting them... I'm hungry now. Anyway.
Yeah. This is when invoked with multiple arguments, a function will only set one variable in the list, and then it returns a function with one less argument that is then immediately invoked.
And this is kind of weird.
Yeah, it is.
When you come from, especially the way, the way I learned programming.
But it makes sense when you understand that there are no state changes, or the changes in state don't affect the function.
Right.
So it
it's
makes
a way
sense
of
looking at
unpacking
yes.
multiple variables so that you get the thing on the first one and then you can get it on the others.
Mm-hmm.
It's very strange until it'll click, but I don't know how to make it click for people.
Well, like I said, it's one of those things that just makes sense given the other restrictions within.
Right, because it absolutely does not make sense if variables are mutatable.
Yes, exactly. Speaking of variables, we have free and bound variables in lambda calculus. Now, a bound variable is one that is bound to the lambda expression and can be replaced by any input. It's one that is, when lambda calculus is written, it is...
There's some hand motions happening here, by the way.
Sorry. Look at the show notes for this one because it'll make more sense on there. But if you have lambda x dot plus xy as your expression, your lambda expression, the x in there is...
Not the outer.
The x in the expression is bound. The y is not.
Oh, yeah. It's bound to... what's being
passed in, yeah.
Right.
Whereas the y is a variable within the function.
Right. We refer to this as scope.
Yes. There you go.
You know, like, bear in mind with any of this stuff, like, do not allow yourself to be intimidated by it, because most of the time they're talking about stuff that's pretty similar to something you've already got.
That's true, and it may just be my math nerdiness that I didn't put the scope and that together. They made sense in their own different worlds.
Right.
Which is why working together makes perfect sense for us.
Yeah. And then, of course, your free variable, it's a variable within the expression that's not affected by the input because the input has no idea that it exists.
Exactly. You know, and it can be acted on by the variable that is brought into it, like the input variable, the bound variable that is affected by the input. They can be added together to produce
the result.
The result, yes. Yeah.
Yeah, it can be involved in an interaction.
Yeah, involved with it, but it's not related to the input.
Right.
It is just within that function. Its scope is just within that function.
Yeah, and the next thing from lambda calculus is beta reduction. And that is that bound variables can be replaced by the inputs they represent. And that's basically where you have a function that's calling another function. And if the first function's got an input coming in and then it's passing into the second function, it's that whole transitive thing from mathematics.
Exactly. That's exactly what it is.
Yeah. This makes me want to like smack an academic, just a random one, because it's like, why can't you explain this in English?
Well, I'll be honest with you. I read this and I'm like, okay, what is different about this from just your basic functions in algebra?
There isn't. Algebra is what it is.
Yeah.
Yeah.
That was my thoughts on lambda calculus. I'm like, it's got to have like something extra to it, maybe like stricter rules about things or something like that. But these are kind of the basic things that I found that I was like, all right, these make sense. And from my understanding of functional programming, I can see these in functional programming. Next, functions are pure.
But not chaste. Too many inputs. A function called with the same input repeatedly will always have the same output.
Yeah,
that's
exactly.
Basically what they're saying. In other words, it doesn't do anything under the hood that breaks its ability to continually return the same output from the same set of inputs.
Mm-hmm. It's not dependent on state. So if you change the state of the program, the function is still going to give you the same output with the same inputs.
Right. So if I have a function that does addition,
yes,
and I always pass in 2 and 2, it's going to return 4, period.
Exactly. Regardless of Big Brother.
Right.
Well, Orwellian joke for you guys there that have read 1984.
Yeah, Orwellian jokes are the best jokes, but don't laugh because you'll go to re-education camp.
Speaking of re-education camp, there are no side effects in pure functions.
Right. And a side effect is what happens when you modify something outside the scope of the function. So something got passed in, or God forbid you have a global variable somewhere, you alter that, it's no longer a pure function.
Or if you throw an exception, you write to a file, read data.
You mean write data?
Read data or write data. This is considered if the data is not passed in.
Yeah, and the thing about reading data is you're still mutating state somewhere because there's a transaction log. Mm-hmm. So yeah, I mean, I get it.
And so the thing about side effects is this is the most common way that programs interact with the outside world.
Yeah, it's through side effects.
Exactly.
Which is, sounds kind of like a prescription drug advertisement, really. It's like, because it's like, this fixes male pattern baldness, but it also causes hair loss, anemia, cancer, possession by the prince of darkness, 15 other things.
Wait.
Right.
Wait, it cures male pattern baldness, but causes hair loss.
It was an outsourced contractor. What can we say?
Well, yeah, but no. The thing here is what is called a side effect is basically anything that the function does that is not the return of the function. So any communication it has outside of itself that is not what it returns.
Right. And so, I mean, it can have, presumably by this rule, it can have a variable within its scope. It instantiates and it alters, but the variable never leaves the function.
Exactly.
That's okay. Mm-hmm. It's just when it's something that it doesn't own.
Yes. This could even be writing to the console or writing to a log.
Because you're altering a stream.
Yeah.
somewhere. And
Next.
we'll get into why the pure function thing is a goal that you don't get to. It's a goal that you're asymptotically close to.
Yeah.
And that's what you're supposed to be doing. But we'll get there in a minute.
Yeah. Variables are immutable.
So in other words, variables don't. Right?
Well, they're constants. They're not variables.
Yeah, they're, another way to think about variables, a function that returns a single value, like takes no inputs and returns a single value is a constant function.
Yes.
Right? I mean, that's really what these variables are, as far as that goes.
Basically, they can't be modified after initialization. Once it's set, it's set. This helps to maintain state throughout runtime.
Right, because you don't have to worry that, okay, I've got this variable, did something else change it? Mm-hmm. Like you don't have to do any kind of weird checks or do semaphores and start screwing around with threading and all that kind of stuff. It's like, no, I have this variable, I'll get the value out of it, and I'll go on with my life.
Exactly. Which it can be useful.
Yeah, it's crazy useful when you have to do really big computations and not actually touch something external.
Yeah.
If you can do it under those constraints, then you can scale out massively better with a functional programming style.
Then what you can do is to create new variables. Basically, the constructor is the only way to mutate state by creating a new variable. Just like, already created variables, once you initialize it, new variables won't change.
Right.
So, if you need to make a change in a variable, pretty much have to create a new one.
Right. Or you call a function that takes an input that ends up being used in the creation of that new variable.
Mm-hmm. Yeah.
Yeah, and you call it a second time. Right. Because, that's how you would manage that scope.
Exactly.
You're going to have to use the native constructs to do that.
Mm-hmm.
And that's completely okay.
That makes sense. Yeah. Next, functions are first class and higher order.
Yeah, and it's not only in functional languages that you see this, right? That's pretty common in pretty much anywhere that you have the concept of callbacks.
Yeah. Because
it's, hey, I can take a function and treat it as a variable and pass it around, which really is just an expansion of the concept of, what that really is a variable is a function.
Yeah.
Period. It's just whether it returns a constant or it returns something based on what I put in that tells me that.
But this is required.
Yeah, for a functional language.
Yeah.
Because otherwise you're going to have a bad hair day trying to get around the constraints of this system without that being available.
Exactly. So first class functions, like you said, can be set to a variable, and you basically treat the function like a normal data type.
Yeah. And let's jump over the side real quick on something, because JavaScript functions are a little different because they're sort of classes.
Yeah, that's true.
Like we're not talking about just like if you're a JavaScript programmer, like, and you have experience in something else, set the JavaScript to the side because this will not help you right now.
Yeah.
Where we're going.
Is you can treat functions like a normal data type, but they execute at another point in the runtime.
Yeah, and that's the thing with them being used so much in callbacks.
Yeah. Higher order functions accept or return a function. Yeah. So like they can either accept a function as one of the inputs, or what they return is a function.
Yes.
These can be like your map functions that iterate over a list, modify some data in the list, and then returns a new list.
Yes, and now that is a JavaScript example, right? Because MapReduce, that's what you do. You say, I got a list, .map, and you pass a function in that takes a parameter. What's the parameter? Well, the parameter it takes is the item currently in iteration.
Yeah.
And then you do something to it and you get a result out.
That makes sense. I was thinking in C# terms with link and lambda expressions in link.
That's a select.
Yeah. Select,
it's also where. Yeah. Most of the link stuff, it was
first or default. There's a lot of stuff there, but yeah, exactly. And then there's the filter function. This made me think more of JavaScript because I've used filters in JavaScript more.
That's aware, by the way.
Yeah.
In case we're keeping tabs.
I got that, but it's basically returns a new list of selected items.
Right. That match the criteria.
Mm-hmm. Some fun examples for you from other languages.
The thing is if you're using a modern programming language, these constructs are probably already there.
Yeah.
Because you need a lot of that stuff for other things just to work, even in pure object-oriented type things, you're going to have things like callback functions and eventing and stuff like that. So you have functions as first-class citizens. You can usually fake an immutable data type as well. So as a result, it's possible to write somewhat functional code in languages that were never intended for it.
Oh, yeah. I've seen some interesting stuff like functional JavaScript.
Oh, yeah.
And read a couple of blogs when I was putting this together on functional Java.
Yes.
Which that's a really interesting concept because Java was like written to be object-oriented. It's like the Haskell of object-oriented languages.
Yeah, it's really, Java is really the Genghis Khan of object-oriented languages. And by that, I mean, it's God's punishment for using, sorry, to excess. I'm just kidding to the Java programmers out there, but I was around 2001 to 2010 when it was kind of going in that direction.
Yeah. That's great.
Yeah. That's going on a t-shirt somewhere.
Yeah.
Right. So I guess let's move on to point number 5, referential transparency. And what they're talking about here is you can replace a function with the value it returns anywhere in a program, and the state of the program will not change. Now, you experienced this in algebra, right? If f of x is equal to 5, then what, let's say g of x, or g of f of x, right? Like I could say g of 5.
Yes.
And I get the same result because that's basic algebra.
Well, you take all the instances where you call a function and you just replace them with the output of that function.
With those parameters.
Yeah. And to be referentially transparent, there should be no changes in the program whatsoever when you do that.
And a lot of this kind of comes down to the way compilers work, because if it is known at compile time that, hey, this thing is going to return a constant value for this set of parameters, I can inline that result instead of a function call and a stack jump and all the other crap that comes with that. I can just say, hey, this returns 5. Put a 5 there.
Yeah,
bro.
Exactly.
And, I love it when your compiler calls you bro, because that's something that totally happens.
Well, and his compiler.
Yeah, well, I got the Purple Dragon book, so what can we say? Now,
where this falls apart, though, is with void functions.
Yeah, because they don't return anything.
Exactly. But the function does something.
Well, it's going to have a side effect if it's a void function.
Yeah.
In general, like, what else are you doing with it? Like, nothing's coming out on your end.
Exactly.
So why are you calling it if it doesn't do anything inside there? Either it's a no-op. So yeah, there's a pretty good reason for that. And I guess now let's get to the moment at which we swill beer and we talk about the assertion we made earlier about how the whole side effect thing doesn't happen in pure functions.
All right, so guys, we've ended the talk on the core concepts of functional programming, and we've hit, the point that smacked me in the face like a 2x4.
Yeah.
As I was going through this, I've been interested in a lot of the concepts of functional programming. When we went to the Music City Code Conference, I took every class on functional programming they had, and it was really fascinating, a lot of fun stuff.
But this didn't hit really until you wrote this outline.
Yeah, this didn't hit until I really delved deep into functional programming, but it hit me, and it hit me hard. I came to a dead stop because of it. And that is...
I think you actually messaged me.
I did.
When you were writing this outline, because you're like, bro, how's this even useful? Right?
Yeah.
Because it's like, okay, this doesn't have side effects. Well, if I don't have side effects, I can't write to a log. I can't write to a database. I can't mutate state anywhere. And you can't.
No.
Pure functional code, you don't do those things. It's a way of manipulating a set of state and a set of operations that do not have side effects. You're going to have impure code in there if you have to do those things. You try to keep it to a minimum, but it's there. Like, that's what that paradigm does, right? It's a concept of, okay, I'm going to organize my code to get as much of it functional as possible so that it limits the number of places where I have performance issues and I have all the other things that come out of non-functional code.
And part of it too, I think, is where my work has led me, in that it's taken me to, I don't want to say just writing CRUD apps, but a lot of what I do is talking to a database, manipulating data, pulling data back, manipulating it, and then putting it in, doing conversions, things like that. And so for what I do...
But you are using functional.
As I was writing this, I was going, oh, well, we're using functional there and there and there. And, that's kind of functional and this is functional. And like the thing I like about .NET, C#.NET at least, is it is functional friendly.
Yes. And I want to talk about link.
Yeah.
Right. Because if I have a link query, until I enumerate it, I'm pretty sure that is actually pure functional code.
Yeah, I would agree with that.
Because it's like, I do, from X in whatever. Okay, I don't really want to use that syntax. It's let's say list of whatever is right. And then I do dot where, right? What does that return me? Well, it doesn't return the result. It returns an expression tree. What's the next thing? It's dot whatever, but that is a extension method.
Mm-hmm.
Right. So the first thing being passed in is the current expression tree, and then it takes it and looks at it and says, here's your new expression tree. Doesn't alter the old one.
I told you how much I enjoy writing extension methods.
Yes, they're great.
Yeah.
But functionally, what's happening is until you get to the point where you enumerate the list, that is, I'm calling the dirty function that goes out to the database.
Yeah.
You are writing pure functional code. Most people do it on one big dump, but you don't have to.
You're right. You don't have to. And for example, the search functionality that I created for one of the apps at work, all right, what I wanted to do was reduce the number of calls to the database we made.
Right.
So we created a hierarchy of the different search criteria. So you submit it and it goes through and it looks, all right, is this null? Then we're not going to, is this field null? We're not going to look there. And it goes down that criteria, and when it hits one, then it calls the database and it pulls everything that matches that one. And then it puts that in a list, and from there on out, it doesn't call the database again. It just reduces that list. And so that call to the database wouldn't be functional.
But it's a subset of the list that gets returned.
Yeah.
It doesn't delete from the list.
No, it doesn't.
Right. So it's functional after that point.
Yes, exactly.
And this is the big thing. Now, this may not seem like a big deal to you, but with some of the stuff that I've messed with stuff like gene expression programming, and this is really, really handy because what you do there is you have an expression tree, and you typically do a depth first serialization of that expression tree to get a stream of content. The arity of the maximum arity of all the functions, the maximum depths that you will allow. And as a result, the maximum length of a byte array that will represent that expression tree. If I have two expression trees, I can make 2 byte arrays. Then I can apply genetic operators. And so it's just like genetics in biology. I can take the first chunk of this byte array, a chunk of the next one, and a chunk of the, and break it, put it back together and come back up with the expression tree. If I know that those expression trees can be manipulated without side effects, I can do this massively in parallel, which is why these algorithms work the way they do. Because genetics is stupid slow. The only reason that you have actual evolution is because you have a population with a crap ton of instances, some of which are shared. And so that allows you to have a lot of optimizations happening in there because you're using functional language versus object-oriented. You do it object-oriented, you're going to have a bad time because you're the whole state issue.
And it seems like the more I looked into it, I'll just be honest with you guys, the further I've gone into this, it seems like functional has its place. It may not be in CRUD apps. It may not be the best choice for writing a pure CRUD app. We've mentioned this before, but CRUD is create, read, update, delete.
It's a paradigm that you use within there. Like, for instance, let's say that, I'm pulling data from a database, right? And I've got this wad of data. Well, I transform that data before I send it to the client in some manner. Well, that transformation can be functional. I pitch it down to the client. the client says, okay, I'm now going to create a control tree out of this. That can be functional. Then you say, okay, I'm editing something client side, right? I'm typing in some fields, whatever. But what's really happening is I still have this DOM tree, and now I'm going to apply a function on it to get a result. Mm-hmm. That's functional. That goes back over the wire. That comes into an expression tree that says, here's what I'm going to do to the database. And then you go back to a non-pure function to push it in.
Well, that's kind of what I was getting at, was that it's more you use functional as, and there may be other, because most of what I've done has been around kind of the CRUD app, but there may be other apps where you're not writing to a database, where you're just calling in or you're just putting in a value and it's working on that and then producing something out. I mean, that would be a pure functional. And I've listened to podcasts where there was a guy that wrote a mobile app that is purely functional.
Yeah, and it's doable.
I mean, it is.
It's like writing one that's pure object oriented. I mean,
yeah, it's doable if you, depending on what you're doing,
and it's doable within a bounded context.
Yeah,
I mean that's something that I think a lot of people really don't get. Like, we run into this with object oriented code, right? There's a ton of people that think they're writing object oriented code, and they're really writing procedural with objects, and that's not the same thing.
Oh, I've run into that.
Yeah. Oh, I've written it. I've written loads of it.
I've written it too, but but I knew I was writing it when I wrote it. I've run into people who thought they were writing object oriented, but were writing procedural with objects, and I pointed that out to them. They're like, "No, this is object oriented." I'm like, "No, it's not."
Because you start having things like dependency injection and all that stuff that legitimately comes with going, I'm separating concerns, single responsibility principle, and you end up with Java.
Yeah.
Like as it was, circa 2010, you end up with that thing of, okay, I've got to have a hammer factory. I've got to instantiate one of those with, some dependency injection framework. And then I can call a function on the first one to get the hammer factory. And then I can call a function on that to get the hammer. Like, you end up in these morasses of this idea that I'm going to code a certain way, and this way is biblical truth essentially, and I've got to follow this no matter what. And it's like, no, dude, it's not a choreographed sword fight on screen. It's a knife fight in an alley. You do what works, or it doesn't work.
Well, I'll be honest. Most of what I code on the back end, especially, is a functional object-oriented blend.
Yeah. With as much functional as possible, and then object-oriented where you can't, and then procedural when you can't do that.
Yes, exactly. That is exactly how I code, because that is what makes the app work best.
Yeah. So far, that's what we found.
Yeah. That's what works best for me doing what I'm doing
with
now.
The language you're using in the environment you're using it.
Yes, exactly. And that works. I just find functional fascinating. I find the whole functional movement interesting, and I wanted to learn more about it because the more I've learned about it, the more I like it. And then I delved really deep into it, and I hit this, and it hit me like a 2x4 in the face. I was like, whoa.
Yeah, I can't do I can't do anything with this.
Yeah, I'm like, my whole career, which true is only a couple of years, but my whole career is based on writing to a database and reading from a database. Yeah. If I can't do that, what can I do with functional?
Yeah, well, and I'll give you another example too. It's like if you've ever used a garbage collected language, which you have, C#, there is the concept of things that are not managed by your language runtime. They're owned by the operating system. They're owned by some C code that you brought in. Those things have to be there for you to interact with the environment. You can't say, oh, well, I'm going to manage this. It's like, no, you're going to have to manage it the way that thing thinks you're going to manage it, or you're going to have problems.
Exactly.
But you keep that to a minimum and you keep it isolated. And that's what you're really trying to do with this functional stuff, is not necessarily use it everywhere, but understand where it can be used and the assertions that are made out of using it. Based on those rules, there's a whole lot of things that you can derive that help the compiler, that help threading type operations, that just in general make everything work faster and better. and that's where you use it.
Yeah, and before we close everything out, I do kind of want to review what functional programming is, because I do think it's useful in the right context. And so functional programming is based on lambda calculus. Functions must return the same output given the same inputs, no matter the state, and cannot affect anything outside of the function. Functions can be set to variables and can return functions or be given functions as arguments. Objects and variables cannot be changed once they are initialized. And finally, if you replace the function call with the output of the function, it should not change the state of the program. That about wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
So I want to go ahead and get my rant about academia out, because this is one of those places like AI where the academics tend to put things in a way that really doesn't help very much as far as actually understanding what's going on. It helps academics communicate with each other when they already understand what's going on. And I just want to caution you that anytime you see somebody barf up a bunch of equations on something, that there's probably a better way of intuitively understanding that thing than the way that they're putting it. And we talked about all this stuff with functions before, but it's an idea of, okay, the thing doesn't alter anything that it doesn't own, right? That's what the function does. And they'll put so many words around trying to say that one thing that it's absolutely insane. And I just want to caution everybody to, instead of, when you read something that is using mathematical notation and putting a whole lot of constraints around stuff, is to try to figure out how to simplify what they're saying into plain English before you try to understand it. Because usually when you do that and you go, okay, well, what is an actual usage of this thing? It really makes a lot more sense. And it's unfortunate that I learned this in math after college, because I really think I would have enjoyed math a whole lot more. Math is supposed to get you out of work. And there's a whole lot of people whose job it is to do math, and so they want math to do a lot of work, because otherwise they don't get paid. And that's pretty much my main beef with academia right now, is they have a very strong tendency to make very simple concepts very difficult. One of my main irritants in the study of biology is the way that evolution is explained. Because what's really going on has to do with, shifts in population and tendencies to move in a direction based on inputs in the environment. Whereas the way that it gets explained is not that at all. Once you understand it at that intuitive level, it makes a lot more sense. And I know Beej struggled on this outline because I struggled reading it. And it's a thing. None of this stuff is hard. It legitimately isn't. And you need to find some way to counteract the people in your life that make things so mathematically driven and so incomprehensible so that they can express things perfectly, that you can actually understand what's going on. And this is true really anywhere, right? Like you've had legal contracts before, and they're going, okay, well, I'm going to pay this and I'm going to receive this value. And that's what the two people entering into a contract actually want to know. The lawyers, on the other hand, want to know, well, what happens if you pay me with counterfeit money? Do I get the thing back or not? See, they've got a whole bunch of special cases, and that's what mathematicians and academics deal with. So figure out some way that you can look at this stuff and go, okay, how can I intuitively understand it in the way the typical plebe understands it versus the way the lawyer wants to understand it, or the mathematician, because they have specialized disciplines that are specifically about symbol manipulation. And that's not what you're trying to do. You're trying to get stuff done. There's nothing that will help you in programming nearly as much as figuring out how to distill what academics are saying into something that's comprehensible by normal, well-adjusted people. And I guess that's pretty much all I got. If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.